So as I was saying, we started out, we've been working with variables. We have like an int number, then assign it some kind of value. So with these variables that we've been creating, we can only hold one piece of data in each one. Even if we sum up a bunch of numbers, it's still only holding the sum, which is one piece of data. Well, now we're getting into arrays. And these arrays, when you see these square brackets like this, that means we're going to be working with an array. So these arrays can hold multiple pieces of data. So we can hold five numbers in an array compared to a variable. We can only hold one number in a variable. So what makes working with data, doing collections and stuff a lot easier. So looking at our slide here, given the specifics or specifications for an application that requires the use of a one-dimensional array, rectangular or jagged array, write the code that works with the array. Given the specifications for an application that requires the use of one of the collection classes presented in this chapter, write code that works with the collection. Like I said, there's like 50 something slides in this. 75 actually, I thought it was 50 something last night. But we're just going to talk about arrays for today. I'll cover the different types of them, how to work with them, how to manipulate some of the data on them, how to use for loops to walk through them and get some data out of them, how to put data into them. Tomorrow we'll do lists and how to work with lists. They're a little bit easier, if you ask me, than arrays. And then I'll do some code demos tomorrow on some parallel arrays and doing arrays and stuff like that, and even a little bit with lists. So distinguish between a loop and a for each loop. Explain how the array class can be used with an array. Describe how the null conditional operator works and when you would use it. Distinguish between an untyped and typed collection class. And describe the differences between these collection classes: list, sorted list, queue, stack, and array list. Like I said, most of that we'll kind of cover tomorrow. There's just going to be a lot to ingest today, and we use arrays quite a bit for the rest of the chapter, so I'd rather take our time, make sure you understand arrays before we dig too much into lists. Like I said, in the real world, when you're working with databases and stuff like that, when you bring data back from a database, most likely you'll store it in a list. It's just easier. Arrays, you have to tell it what size you want the array. A list, you don't have to do that, so your list can grow or be whatever size you need it to be depending on what you're returning from a database. So the syntax for creating a one-dimensional array. So you have the type, and that again is like the data type that we've been using for our variables all along. So you have the type, and you have the square brackets. When you have that square brackets, that's saying that you are going to create an array or that you're working with an array. And then you specify the name. And this is a way to do it with two statements. So then you have your array name. You give the equal sign. You say it's going to be a new, the type of array and the array length that you're using. And then you want to do it on one line statement. More often than not, you'll see it on one line than two. It's up to you on how you want to do it. Both ways work. So you have the type. Again, the type is the data type. You'll have an array name and new type and the array length. So you'd be looking at something like this. So the type, again, is the data type. We've been doing this all along with the variables and that we've been doing. Then we're going to say that we're going to use an array. Again, the square brackets show that it's an array. And then you just give your array a name. Usually with an array, because we're putting a lot of data in these arrays, you're going to make it plural. So it's going to be numbers. Again, you still camel case it even if it's plural, so we could do like numbers count. So you want it to be a plural name because we're going to be holding a bunch of data usually in these arrays, and you still want to camel case it, so if you name it with 2 words or whatever, just make sure it's camel cased. And that's how you can do it on 1 line or 2 lines. So an example would be I do numbers count, and then equals new, and then since it's an int, we want to keep it an int, and then we're going to tell it what size we want. So if we say 4, it's going to hold 4 values for us, so we'd have something like 1, 2, 3, 4 inside our array. We tried to go 5. If we're printing this out, we try and print out a 5th one, we'll get an array out of bound index or out of index, kind of a notice saying that you're trying to pull more data in or pull more data out or push more data into an array, and it won't work that way. So tell it how many pieces of data you want in the array when you do the new int 4. So we're telling it we want 4 pieces of data in there. When you access this data, it's called an index. So they use an index or a substring to give these datas a way to pull them out or access them. And in an array, I know it's going to be crazy sounding, but it starts out at a 0 and then goes 1, 2, 3. So if we're trying to access the 1, we say it's at subscript 0 or index is 0. And when we say index is 0, we actually get that number 1. So as you're counting through an array, it always starts with 0 and goes to whatever the end of the array is. So if we have 10 things in an array, it starts at 0 and it ends at 9, but we still pull 1 through 10 out of it or put 1 through 10 in it. So that's something you're going to have to kind of get used to, is the index. And the index is the number you use to access the values in the array. The index will start at 0 all the time, and you just call it like that. And there's going to be some examples here in the slides in a minute. So examples that create an array of decimal type, and you can see they're using a data type here, a decimal. Square brackets show it's an array. They're naming it totals. And you can see the S on the end, it's totals, because with an array you're holding a lot of data in it, and you usually want to use a plural name. Then they reassign the value for totals, give it a new decimal, and saying there's 4 pieces of data inside this array. And again, when you declare it, after you assign it, that you use the type again and then the array length inside that square. So that's why you usually see a number at the end of it. Here it's doing it all in one statement. They're doing decimal, totals equals new decimal 4. So they're just saying use the data type decimal. Square bracket means it's an array. They're giving the array the name of totals, and then they're assigning it a new decimal with 4 values into it. Same thing we've been doing with variables almost this whole time. Again, just giving it a data type and then a name and assigning it a value. But now we're using arrays to hold a bunch of data in it instead of just 1 piece of data. But we still have to declare the data type. We still have to tell the computer that, hey, we're using an array with the square brackets. Here's the name of our array. Then on that next line down, it's saying, create us a new array with 4 pieces of data in it called numbers count. So that's kind of what you're looking at on the board up there. An array of strings is done the same way. You just do string, data type is string, the square brackets is array. You give it a description of what the strings are going to be. A lot of times it's going to be like employee names, employees, employee salaries, stuff like that. Movies, I think we do one where we search a movie database, so you have movies, games, stuff like that. And again, with your description, you want to put an S at the end usually just so you can tell that there's going to be a lot of data in it. And then same way, give it the new keyword here. String is the data type again, and they're saying put 3 pieces of data in this array. Let me check my code real quick, see what I got up here. So, give you an example of how to do some of this stuff here is got my little form here. Whoops. Got my form, my button click. So declaring an array, I'll do an array of strings to start out with. So I just do string, give it my square brackets, not the squigglies, square brackets, give it a name, and I'll call it student names. And if I want to do it on one line, I just do new string. And it's already kind of, IntelliSense is knows I'm doing an array, so it gives me the square brackets. But in the square bracket, you need to put a value in there. So I'll do 3 for 3 names. And then they put squigglies behind it. The reason the squiggly is behind it is because you can put your data in there with it like that. So I could do like John Smith, I believe, and I might have to redo this. I have to remember John Smith, and it looks like I am. So what I'd have to do is do student names equals, and then I could do squigglies, and this will put values inside of it. So I can do like John Smith, Joe Bob. Why is it not happy about that? Is it semicolon? I thought it was just a comma. Joe Smith, Joe Bob, John Smith, Joe Bob, G, and that's my 3 values. I gotta figure out why it's mad. That should be how you do it. Let me double check my stuff here. It's been a while. Yeah, that should be how you do it. Let's go look at the slide real quick. So on here they're doing a constant, an integer called max count, and we know it's a constant because it's in Pascal case. It's got the capital M and a capital C, assigning a value of 100. They're doing another decimal data type for an array because we got the square brackets. They're naming the array prices. New decimal array, and inside this array they're putting max count. So they're setting this array size to 100 since they have this max count set to 100. So that's the way you can do it there. Then they got a new variable called discount percentages, and inside this discount percentages they're putting a new decimal called max count in here, so it's 100 again. That's kind of how they have it set up. I think they use it here in a bit. I'm getting some discount percentages set up. Default values for array elements, numeric is a 0. Char is the quotation mark /0, quotation mark close. Boolean is false. The date time is always January 1st. And a reference type usually is null. Syntax for referring to an element is you, like I was saying up here, you use an array name and the index number. So a way I could set this up and put values to it is like this, just because I know this one will work, is a student names 0, and then it'll be Billy Bob. And so now the first element in our array, and you can see it starts at 0 like I was saying earlier. Our first element will have the name Billy Bob, and I can do student names 1 equals Joe Smith, and then student names 2 equals Sue Jones. So now we have an array of strings. You have a question, Leon?
It's not about that. It's on the test. There's a answer with like 2 of the same.
Yeah, go ahead and pick one, and I'll fix it. Yep.
So for these arrays, are we basically giving each of these names like a group ID or something?
No, what we do is for the arrays, we just give the array a name that we're going to use. So if you look, like my array name is student names. And then we tell it what size we want the array to be. So we're telling it we want it 3 here. And so this 3 will hold 3 names in it. So if we try and put 4 in here, I don't know if it'll actually do it on here.
So it's basically like giving student names like 3.
Yeah, so we're taking student names and we're putting 3 values in student names.
Okay.
So we're putting 3 student names in our array called student names. Before, when we did variables, we could only put 1 name in each variable. So we'd have like person 1 equals Billy Bob, person 2 equals Joe Smith. But now with these arrays, we can put all those names in just one array called student names. So now we don't have to necessarily go student 1, student 2, student 3, even though we're kind of doing it here, but they all get collected under the student names. So as I go through here in a second and show you how we can access these a little bit easier than having to call each student by themselves, these arrays make storing data better because it's not taking up as much memory as putting them all singly. They all kind of stay together in memory, so it accesses them a little bit quicker.
Is there a reason you deleted your last line?
Which one was that?
When you said student names and then put a comma after comma?
I was having some errors with that.
I didn't feel I was wondering.
Yeah, and
I'm trying to call it out as in student names bracket 0, but ain't nothing happened.
yeah, and so I'll show you how to access these here in a second. You usually use a for loop or a for each loop to walk through these and pull out the names as they come. So let me see if I put student names 3, if it'll actually give me an error here. And it might not at this point, but when we try and run it. So it doesn't here, but when we try and run it, it's going to give us an array out of index because we have more names listed than what we set our data size to be for the array. So I don't know if it'll actually do anything at this moment. Let me see real quick. LBL, what did I call my label? Result, text equals student oops, I put it outside my method, no wonder. So now if I try and run this and print up my label, it should give me an error saying that its index is out of range. And there's my error. It says system index out of range exception. Index was outside the bounds of the array. And when you get that, it's because, like I said, I'm trying to call name number 4 technically. This would be 1, 2, 3, 4. Trying to call name number 4, but I tell it there's only 3, and because of that, it gives me a range out of index, out of bounds. So system index out of range exception. Index was outside the bounds of the array. And, yeah, Matt.
Curious, is there any sort of like practice in the real world to kind of get like around that? Like, do you set your array to just be like a very large number?
You can, but that's not really recommended because you use up a lot of memory space and stuff like that, because it's leaving space for 100, but you're only putting 3 in there, so it eats up more memory. And that's what the nice things about lists are. When we start talking about list, is you don't necessarily have to give the list a size. It dynamically expands as needed. So like a list, and we'll get into it more. So like your list is 3, you set it for 3 and you can, but you put a 4th one in, well that 3 will double to 6 to make sure it can hold whatever else you're putting in. You go to 6, you put in a 7th and it'll double it to 12, and that way it always holds more than what it needs to, just in case. Yeah, Paul.
Aren't the arrays like way faster though?
I wouldn't say way faster, but yeah, because you're setting a size and everything for it, so it's kind of holds it in memory that way compared to, yeah, compared to like a list that where it's holding a little bit extra and just the way to access it. Yeah.
So like for testing, like say we were just working on an app, could we just set the array to be something silly like 100 and then I'd go back and change it later?
You can, but it's not really recommended to do it that way.
Okay.
You're better off just setting it for the size that you need. If you're not sure of the size, I would use a list more than likely. And like I said, in the real world, you'll end up using a list way more than you do an array, just for that reason, because you don't have to worry about the size of your array or list coming back or anything like that.
It seems like the only time to really use an array is like a jagged array, like a multi-dimensional one or something like that.
Yeah, and that's like if you're comparing stuff and trying to hold data together, would be more like that. But like I said, in the real world, when you're returning stuff from the database and that, you're going to return a list, and then you can always search through a list and stuff like that. I don't know, I didn't go far enough through the slides yet to look and see that if they show us how to do that. I'm sure they do somewhere, because as we switch from arrays to lists, we're going to still be doing searches and stuff like that. Yeah, Henry.
Can't you just like store all the names in just like one line?
Yeah, and I'll show you that here in a second. So like if I want to get rid of that error I have, I'd have to change this to 4. Now it's showing I can hold 4 things in my array. So I run my array again, click on my data, and it brings up the last one, because I'm telling it bring up the 4th element in my array, count down 1, 2, 3, 4, and there's the 4th one. If I switch this to 0, what name should I get back?
Billy Bob.
Billy Bob should come back.
So Mr. G, I just did it in that one line,
Oh, I didn't mean that, because that's,
and I didn't have to put that new string with the array number for what it showed. I got it off W3 Schools, and it worked perfectly fine.
worked all right like that.
Yeah.
This is the recommended way of doing it. The book tells you to do it that way. You don't necessarily have to. I know you can just call the array, name it like that, and
That
just.
one from W3 Schools let me put it in one line, though. That's the only reason I'm saying.
Yeah, yeah. So like I said, if I put 0 in here, I put it in the wrong place earlier. If I put the 0 in there, I should get Billy Bob back as my name. So yeah, Billy Bob. So then if I want to loop through this and save myself some time of having to put an index in, I can do something like, let me see how I have this set up. So I can do a for loop here. I give I value 0. I'll do an I is less than student names dot length. And when you're accessing or looping through an array, what we do is you use the array name, which is here. You can see it's student names, and then you do a dot length on it. And this dot length, what it's doing is getting the length of your array, the length of the elements inside your array. So now we know, like before we were doing for int I equals 0, I is less than or equal to like 10, or giving it a number or something like that. Now we're using this dot length so it can go into our array and just get the value of the length out of our array. Know how many times it should loop through. And so now I can take my label result. And with these for loops, we have the squiggly brackets afterwards. If you do one line of code, you don't necessarily need the squiggly brackets. So as an example, I can do student names, and I'm going to use I for the index now. And I'm going to do \n, \n, and I'll put it on a new line for each student. So now what I'm doing is using this index, which we set at 0, and as it loops through, it increases my index each time. And each time it does, it gets that student name. So it'll get the student name for 0 first, print it out, get the student name for 1 next, print it out, 2 and 3 as it loops through. And then when it hits the technically 5, it will stop looping through and end our program. So now if I run this here, just this little for loop will save me all the time of having to print each one of these out and display them. So now I can just run my array, and that didn't work as expected. What did I do wrong? Oh, I need plus equal. That way it keeps adding to them. So now it should do the first one, put the second, third, and fourth behind. Just that equal sign, it was picking up the very last one since it was ending at that last one. That's why it kind of looked that way. So if I run it again, click on my display data, now I get all 4 names. And the reason that first time it only showed me the last one is because with just the equal sign, it loops through, and when it finally stops looping, that last number in here, the index of 3, that's what it picked up and printed out. By putting the plus in front, as we saw on some of these labs we've been doing, it keeps adding the name into it. So like I said, if I run it now, if I run it with just the equal sign, I'll show you again. It's just picking up that very last name. But if I put the plus equal sign, it's going to pick up each name and keep adding it to our array of student names here, printing out. So there we got Billy Bob, Joe Smith, Sue Jones, and Doug G. And that is a lot easier than doing a label result dot text and doing student. Actually, I'll do it like this. So to get all these to print out, I would have to keep going through them like this. And so on and so on, so you can see.
Yeah, I thought if I do it the other way on the test, is you gonna count it wrong?
No. So now if I do it like that, I should get the two names. And you can see student names Billy Bob and Joe Smith. Billy Bob and Joe Smith. I'm calling element 0 and 1, which is actually name 1 and name 2 in our array. Just because we're accessing it by index, it always starts at 0. So you can see doing this for loop, you can do 2 lines of quick code compared to typing out every student name with the sub-index there like that. I mean, you could be typing for a while on a lot of that. If we had 100 names, this is all we'd still have to do, and it'd print out all 100 names for us. 2 lines of code compared to typing every one of these out. Do you have a question, Liam?
Yeah, so what does the for line do again? Like what's I?
The for line here.
Yeah.
So just like we've been doing the loops in our labs for chapter 4 and 5, where we're looping through and asking the questions like, please enter a salary for such and such, and that's what this is doing. It's doing the same thing. It's just saying it's a for loop, so it's going to keep looping through the code until our I doesn't match our criteria for the student name's length. So what we're saying here is we're declaring a variable called I, giving it the data type of an integer. We're setting a value at 0. So now we're going to take the 0 that we just set for I, and I is just holding a value. Right now it's set at 0. As long as 0, and just to show you, I can kind of do it like that because that's what I was. And you could even, I believe, do it like I equals 0 here, but it's just not the proper way of coding it out. So since our I is holding the value of 0, I could just put 0 there as a demonstration kind of thing. And all it's saying is while 0 is less than student names dot length, so we have, what's that?
What's not length?
And like I just said, dot length takes the length of your array and puts it into a number kind of a thing. So we say up here the length of our array is 4, the size of our array is 4. This dot length goes and gets that value out and says, okay, your array data size is 4, your length is going to be 4 because there's 4 elements in your array. So you can kind of think of this length as saying our student size, our array size is 4. So what we're saying here now is I is less than 4 is what we're really trying to say. So we could say something like I is less than 4 because it's the length is checking it. We know our data size is 4, so that length is saying, okay, your array length is 4. So now we go back and look at it and say I, which we set to 0. 0 is less than student name's length. Yes, 0 is less than 4. So go print out the first student name, and that student name has I in here. Well, we assigned I to 0. So then technically the first time through, this I gets set to 0, so it's going to print out the first student name. Does that make sense?
Sort of. I mean, it takes some getting used to. It's hard to understand like why it does that.
Yes, so when this loops through, it goes through the first time, that value is 0, it comes through, it prints this line out here, which is a student name in position 0 in our index. Position 0 in our index, if we look up here, is Billy Bob, so it's going to print out the name Billy Bob. So then it does that, and once it does that, it hits this I++. What's the I++ do? Yeah, it increments our array, or our for loop. So now this I, which we set at 0, it gets switched to 1, and then it says, is 1 less than our student name's length? Well, our student name length is 4 because we set it to 4 up here. So yes, it's less than 4. 1 is less than 4. So let's go back through here again and run this line of code. Well, now this 0, which was an I originally, this I picks up this 1 and gets set to a 1 in here. Well, our index and student arrays name, our student names array 1 is Joe Smith, so it prints Joe Smith's name out.
So, right, basically what you're doing with the increment in the I is that once it increments, like it's going to change the I's value of 1, so it matches like another.
Yeah, so what we're doing now, we're at 1. We've printed out our student name, subindex 1, which is Joe Smith. It comes and hits this increment again. It increments our I from 0 to 1 to 2 now. Now it's saying is 2 less than student's name dot length. And again, we know that length is 4 because we set the size up here in 4. Yes, it's less than 4. 2 is less than 4.
Just put backslash in at the end.
It starts on a new line.
Oh, okay, that's what I was wondering, like how are we going to
So the I that we have in here for our index now gets set to a 2, and we can see up here our subindex and our array, our index is 2. So Sue Jones should print out. Print Sue Jones out, it comes and hits our increment again. Our increment goes to 3. Is 3 less than student names dot length? Yes, 3 is less than 4. So print this line out again. Change our I to 3 since we incremented it and we're pulling it from here. So then we look, sub index 3 is Doug G. So then Doug G prints out, goes back up here, hits our increment again. Our I changes to 4. Is 4 less than 4? No, it's not less than that. So then it stops typing everything out. And then it moves on to the next line of code. So if we set this back to how it was, this is unhappy because I have the line beneath it coded out. I don't need it there. What am I doing? Oh. So now that I got my code back in here, everything's happy. So now we're running it again. And we can run it with the debugger on, and I'll show you how it works with the debugger. Oh, got my window open, it's not happy. So it puts me in debug mode. As you can see, the extra panels and stuff come up. So now if we debug this and I click on this display data, it's going to break as soon as we get to our for loop. There it breaks. Yellow arrows telling us we're on this line. So now walking through a for loop, you can see it sets I to 0. Down here in our little box, we can see I is now the value of 0. The length of our array, student.length, is at 4, and we knew that because we set it at 4. So now we'll go into our array, or our loop. We get to our line here. Still, I is still 0 because we haven't incremented or anything yet, so we're picking up 0. 0 should be Billy Bob. Now we hit our increment. You can see our Billy Bob got set. Our I is still at 0 because we haven't completely incremented it yet. So now, there we just incremented our I. So now our I is going to be 1. Is 1 less than student length? Our student length is 4. Yep. So let's go back down into our code. Go into our code. Now we got Joe Smith's name in here, and you can see our new line here. So we got Billy Bob and Joe Smith now that's getting returned. Our I is still at 1 because we haven't actually incremented yet until we get that yellow off of there. So once the yellow goes off, now our I switches to 2. Our student names dot length is still 4. That's never going to change because we set it to 4 up here. So is 2 less than 4? Yes. So let's drop back in, do the code again. Now we do it again. So now we pick up Billy Bob, Joe Smith, and Sue Jones, since she's our number 2 on our index. And as we see our index here, our I is at 2, so it's picking up 2 there. We run it again. Our I changes to 3. 3 is still less than 4, so let's run this line of code one more time. Now we pick up Billy Bob, Joe Smith, Sue Jones, and Doug G. Our I is still 3 because we haven't technically incremented yet until the yellow code or the yellow highlight goes off of it. We do it again. Now I is at 4. I is equal to 4 but not less than 4, so that's not going to work. So now it should skip over our line of code, and it does. That's the end of it. If we keep running it, it should pop up our screen and give us our 4 names that we just watched it walk through and print out for us. A lot of times when you do for loops, I was always taught that you put the squiggly brackets, kind of like an if statement, you put the squiggly brackets right after the parentheses and then wrap your code in the squiggly brackets. This will work like this too, and then you can put multiple lines of code down here if you need to. I still code it out like this. To me, it's just cleaner, easier to follow and read. If you're just doing one line of code like we had there, you don't necessarily need to do it. It'll still work and run properly. But just old school habit of putting the squigglies after the parentheses like that. And then if you put more lines of code in there than just one, you don't have to worry about whether it's going to run or not. You know it will run. So that's an array with some strings there, looping through it with the for loop to get what we want done. So now if we wanted to create an array with some numbers, we can just do a double. That's our data type again, is a double. What's the difference between a double and an integer?
Double, you know, decimal.
That's right, a double can hold a decimal, an integer can't hold a decimal. Did you learn that on ChatGPT, or did you figure that out yourself? All right. Yeah, we had another talk upstairs about ChatGPT and how it's hurting you guys in the long run by using it. But so we declare a data type of a double, and again, since we're doing an arrays, we want that square bracket there. This time we'll call it employees, Ployee salaries. And then we can do a new double equals new double, saying 4. We can call it number whatever we want to, and say 3. And then if we want to declare it on one line, we just do the squiggly brackets. I believe this should work. And we'll do like 23,000. Why is it not wanting to work like that? Double decimal employee salaries, new double 4. And it should actually work this way by putting the values in. I don't know why it's being stubborn about it. So we'll do 40, 1, 2, 3, and 30, 1, 2, 3, and there we go. I guess because we didn't have the full data types on there, it wasn't happy.
The first time when you were doing a string, you didn't wrap all of it in quotation marks.
Is that what it was? I didn't notice that. Thank you. So this is how you can declare them on one line, just like that. As you do your double, which is the data type, you got your square brackets saying that it's going to be an array, the name of our array, and then you assign it a double is the data type. Square brackets again saying it's array. The 3 inside it is saying we're putting 3 things of data inside. If we wanted to put 4, it's unhappy because if we only have 3, but we told it we want 4, so then we have to put one more in here. And now it should be happy again. So that's how you can put your values of your array on the same line and put them into your array. The way above here is doing it individually via the index. So now if I want to print out the values of that array, I do the same thing I did before. Employee salary.length. And the reason it's employee salaries.length is because that's the array we want to print out. We want to check it on there. What's the size of our employee salary array? Yep, it's 4. We set it to 4 right here, so we know that. We know this length is going to end up being 4. And then I'm just going to do label result again. And then again, I got to do the plus equal to get each one to add to it and show up. Employee salaries. And again, we need the subscript I in there to pick up each one that we want. And I'm going to actually make this a string interpolation. To me, it's just a lot easier than putting all the concatenation pluses and parentheses or quotations and everything else around it. So, and then I want a new line for each one. Close my quotation marks and put my semicolon at the end of the line. So now when I run this, I should get the 4 employee names, and then like right after that, I should get the 4 salaries that we have.
Should we just put it in the existing array?
No, because this array here, we have 4 data, or a size of 4 for it, and it's strings. Well, now we're using numbers, so we're going to have to use the double to hold the numbers in it. So we want a second array like that. And so I could do like Billy Bob 40,000 here like that, and it'll show up because it's all part of my string. But when we're using the 2 different arrays like that, one holding numbers and one holding strings, we have to do it like this. So then if I run this now, the first name will be Billy Bob 40,000, Joe Smith, Sue Jones, Doug G, and then that'll be followed by 23,000, 40, 30, and 50,000. And the reason that is because I'm running this first for loop here, and then the second for loop here with the employee salaries on it. So if I run this now, my display data is there's that Billy Bob 40,000, Joe Smith, Sue Jones, Doug G, and then our numbers 23, 40, 30, and 50. So that's how you do numbers, is just the data type, same as you do a string, but just use numbers instead. You still give it a size. And here you can see they're kind of doing the same thing that we just did. They're doing it by index. So you create a data type of decimal, telling it it's an array, give it the name of totals, a new decimal array the size of 4. There's the 4 values they're putting into it. And like I showed you here, if they did a 4th array, which would be actually 5 numbers, 1, 2, 3, 4, 5, you get that index out of range exception. And if I do it again here real quick, if I change this to 3 and try and run it, we should get an error. And it's a build error because we get a build error right off the bat because we're saying the size is 3, but we're trying to print or put 4 pieces of data in an array size of 3. If I switch that back to 4, it should be happy again, and then it would run. There goes my error down here at the bottom. And then I could run it with no problem again. So you got to kind of keep an eye on your size and how much data you're putting in your array so you don't get those out of range index errors and that. So, and they're doing a string of arrays here, and that's kind of what we did in that first example. You take the name, the index you want it, and then put the name of the person in there. Syntax for creating an array and assigning values in one statement, and we just kind of looked at that. That's what this is doing here, is putting the values in on one line and one statement.
And I see what you mean now. Using that for loop, you can get whatever you want out of the array by just changing what I is equal to.
Yeah, so like,
I changed it to 2 and it gave me my exact.
yeah, like Jamisha's saying here, if we switch this for the student names, if we change this I to like 2 and run it, it only gets the 2 that are left in there, so it starts at 2. So it starts there, picks up Sue Jones and Doug G, but it doesn't get Billy Bob or Joe Smith. Sue Jones and Doug G.
The only one we can singly get would be the last one?
What's that?
The only one we could singly get would be the last value in the array?
If you just leave it like the equal sign and not that plus equal, that will only pick up the last number, because we're just looping through, and each time it loops through, it assigns this I, and because the last one we go through is 3, it assigns that 3 at the very end, and that's what we get stuck with. But by putting that plus there, each time it loops through, it adds a new one to it and still holds that former value.
Okay. I
So
see what you're saying.
yeah, so then our student names goes 0, and then we add, after that on the string, we add the 1 into it, we add that 2 with it, add the 3 with it, and that's how we can get all 4 names picked up. So like if I switch this to 1, we should be able to get Joe Smith, Sue Jones, and Doug G now. Joe Smith, Sue Jones, and Doug G, because we're starting at technically at this element 1
They're not-
instead of 0. So then if I did 3,
That's what gets me though. I wish it would just give me 3 and not give me 3 and 4. You know what I'm saying?
yeah, and there is a way that you can set up some ranges and stuff like that just to pull certain numbers back out of it in a way. And as we go through these slides, you'll kind of see. I'm not going to do too much of a demo on them because in our labs and that we don't use it very much. People want to see a demo, I can set one up tomorrow when I demo some more of the array stuff and the parallel arrays that we'll be using. So like I put this back to 0, we can switch this one down here to 1, and we should skip 23,000 and go right to 40. 40, 30, and 50 should show up. Let me get rid of my other window so this one gets happy. And again, it skipped 23 because of how we set our starting number and loops through the array like that. So this is just setting up an array and assigning values in one statement. You do the name of the data type, square bracket saying it's an array, give the array a name, use the new decimal, we're setting it to 4 spaces, and then you put the squiggly brackets right after it, and you put the values you want in there. And again, since we're using decimal, we have to use the letter M there. If it was a float, we'd put the letter F behind there. Same with strings, you just put string names. Ted Lewis, Sue Jones, and Ray Thomas, all in the same line. So if you're working with an array but you don't know what data types you're actually using to put in the array, you can use this var keyword here. That var keyword, I know in JavaScript we are like, don't use var, that's old school kind of thing. Yeah, we use let and const, and people that haven't taken JavaScript class, we'll go over this when we get to that point. But that var grades is saying, I don't know what data type I want for sure. Let whatever values are in my array pick up what data type I use. So more than likely, with it being whole numbers 95, 89, 91, 98, it's going to say the var type will be an integer for the data type, since that's the kind of numbers we put in there. Heck, it could be a double, it could be a, well, I wouldn't say a float because we don't have an F or an M behind it for a float or a decimal. But it could be a double, it could be an integer, it just depends on what the numbers you put in there. If we put like 95.1, yeah, then it would be a double because we have that decimal point in there and stuff like that. So that's how you can use this var keyword for your data type, and then it picks up whatever is in the array and assigns your data type to it. And you can see the difference here too. It just says new. It's not saying new decimal,
New N.
yeah, or anything like that. It's just saying new array. Let the data type get figured out by whatever data's in there, and that's because of that keyword var in the front of it like that. So if you don't know for sure what type of data you're going to be putting in that array, you can just use that var keyword instead of an actual data type. Then the array picks up what data types are in there, and then it assigns the data type to that var keyword. Syntax for using the length property. Let's take a break here, and you guys can kind of let your brain rest for a minute, go to the bathrooms and need to, get a drink, and we'll come back and start talking more about the length property with these arrays. Syntax for using the length property, we kind of went over this already. Here they're doing a code that computes the average array of totals. Again, the data type for the array is a decimal. We got the square brackets showing that it's an array. They give it the name of totals, and they put the values of their array in there. So they're using 14.95 M for decimal, 12.95, 11, and 9. So then what they do is create another variable with the data type of decimal and call it sum, and then add up all those indexes to get a sum. And then they create another variable with the data type decimal, give it the name of average. They take the sum variable that they just created here and added all the indexes up and divide it by 4. And so then you can actually add all your elements in your array and then divide them by 4. And I have an example of that I'll show you here in a minute. And then here's code that puts the numbers 0 through 9 into an array. So they declare a data type of integer, again the square bracket saying that's going to be an array. Give it the name of numbers, assign it value of a new array with an integer data type and a length of 10. And then they go through and walk through it and print it all out. And so, give you an example of that. So I'm going to comment this out for now so it doesn't interfere with the other stuff we're working on. I got my thing slide over. I was looking for my squigglies and I'm like, make sure I don't comment out the wrong squigglies. So I'm going to do a string, call it number string, and I'm just going to assign it no value. I can do I believe it's empty string or string empty. Let me look here at my notes. Yeah, string.empty. I could do a string.empty if I want, like that, and that just makes the value of that number string an empty string. Or I can put the double quotes like that and just say it's an empty string like that. And of course, the green squigglies are just saying I declared a variable and I'm not using it yet. So then, like the slide shows, I'll create an integer, It's going to be an array called numbers. I'm going to say a new integer array with the number 10 inside of it. Kind of setting it up just like our PowerPoint presentation's doing here. Guess I could copy and paste if I want to save time, but I'm not in a hurry. So then I'll do a for loop again. That way we can loop through all this. And that's when a IntelliSense is kind of nice. It kind of sets everything up for you so you don't have to type everything out. And again, as we do our for loop, we're declaring a data type integer for our variable I, assigning it to value 0. Our I, we're going to check it against the numbers. And again, our array is called numbers. And that dot length checks to see how long your array is. We said it's 10, so our numbers dot length will technically be 10 if you think of it that way. And then we'll increment that I every time it comes through. And then I will do number string plus equals numbers I equals I. So now it should print out. Oh, I got to put my label on here to get it to actually print out what I want it to. And actually, I don't want that. I should have made my notes a little bit clearer since they're all kind of munged together here. So I'll do text equals number string. Is that what I want? I'm going to actually change this around just a little bit to get what I want it to actually do for this example. So numbers equal I. I'll print this out. Equals. So the way I'm printing this out, I'm using this join, and I'm going to join each of these numbers, and I'm going to separate them by a comma. So that's kind of what I'm doing here. And then my label result is just going to print out this result. And so it should print out all 10 numbers. They should be separated by a comma. And there they are. Again, it starts at 0 and goes through 9. The reason for that is because we're starting our I at 0, going through our number length 10, and again our index starts at 0, and that's why it's coming out that way. So that's just taking 10 numbers in our array and then just printing them out to the screen. And we could do that in a, I think they start showing a message box down a little bit further in here. Yeah, a message box. So if we want to do that in a message box, we could do something like this. I don't even remember if we use message boxes much in our demos or not, or our labs, I should say. So I'm going to go ahead and comment this little bit out and redo it. You've messed with message boxes?
It's more like kind of just learning it before anybody else kind of did their thing to that GTP.
Oh yeah. Uh-oh. There's that chat GPT that we were talking. I can't even say the damn word. So to do it with the message box, we could do like declare a string, number string. This is kind of what I was setting up earlier. And I can do the double quotes to leave my string empty, or I can do an empty string.empty to get my string to be empty. And then I'll do an int. Again, that's my data type is the int. The square bracket saying it's going to be an array. Get my array name of numbers. I'll say new int, but we want 10 in here, not 1. And we're going to do our for loop again. Again, IntelliSense is kind of nice that it will save you a little bit of time on having to type out that whole array, or the whole loop. Just make sure you're adding the right array name. Got your .length there. So then I'm going to do number string plus equals numbers I and then my message box dot show, that way it shows up, is going to be number string, and that's the variable that you want to have show up on in the message box, and then the comma, and the next part is the title if you want to give your message box a title. Do it like that. And because it's only one line of code here, I don't necessarily have to have these squiggly brackets on it. But like I said, you're probably the same way old school coding. When you do a for loop, after the parentheses, you usually put the squiggly brackets. Just, I don't know. To me, I like doing it that way. It's just, if you're adding more lines of code, you don't have to worry about forgetting the squiggly brackets or putting them in or not. So now if I run this, I should get a message box. There's my message box. There's all the numbers printed out. There's my title number display. So if I run it again, there's my number string here that I'm setting in my for loop. Prints them out to the screen with this message box show. There's my message box. My number string shows up in my message box, then comma, and in these quotes is my number display, and that's the title that shows up on your message box. I can change that title if I want. Like I said, I don't think we use the message box too much in our labs. Numbers display example, and again our numbers are in there. So I know these slides keep showing message box on there, so I decided to give you an example with the actual message box in there. I wouldn't get too caught up on that. Like I said, I don't think we use it much in our labs. And then here's what it looks like. Same thing we just saw on the screen. A for loop to compute the average of the totals array. Here they're declaring a data type of decimal, given the variable name of sum, assign it the value of 0.0, and again the M is for anybody? No, the M shows it's a decimal.
Sorry,
Yeah, money is a C for currency. And then we do a for loop. It's checking the totals .length, and I got a little example here I can show you of running that. I'll go ahead and comment this out. So I'll do a decimal. Again, it's an array, so I need my square brackets. I'll call it totals. new decimal. Give it 4 values in our array size there, and I'm going to give it the same values they have. I think it's like 14.95 M for decimal, 12.95 M, 11.95 M, and a 9.95 M. All my red goes away because I have 4 values in my array when I say it's going to be 4. So then I'll create a decimal called sum, give it the value of 0.0. 0 would work. I'll do 0.0 since it's a decimal. And I guess I could go ahead and print it out to a message box again. I think they're doing that too. So I'll do string total string equals string.empty again. I did string.empty up top, so I'll do it down here just to show you using the empty quotation mark. Do our for loop. And again, our array is called totals, so that's what we're going to base our loop on, is the length of our totals array up here. Again, we know it's 4, so it should loop through there 4 times. So we're going to take that sum plus equal totals I. And it's nice that IntelliSense does it for you, but you should still need to know why you're doing that. So again, we're taking our totals, getting the index of I that we set here, and then we're just going to add them into the sum. So it's kind of like going back here, we're taking these totals here, but we're doing it kind of a shorthand with that plus equal. And then we're going to do a total string plus equals the I. And I was trying to use the new line on this last night, but it was giving me some issues, and I had to go search around, and I found if you use this environment new line, that will do the same thing as that /n and put this stuff on a new line for me every time I run it. So then I want to get the average, and I'm just going to declare the average down here instead of up top. And we're going to take the sum and divide it by the totals.length. And again, the reason we're using this totals.length is because there's 4 elements in our array, and so that way we know what number to use for it. We set it to 4, so it's going to divide it by 4 for us. And then I can put this in a message box, and in this message box I'll use some string interpolation in here to show that you can use string interpolation. Plus I was looking at that last night and didn't feel like typing all the print or the quotation \ns and all that stuff out, so I was like, heck with it, I'll do string interpolation instead. So I'll do show string interpolation. Again, starts with the $, quotation, and then we can put whatever we want to in here. So totals are, and I will use a new line here just to get it to break and look good on our screen. Our totals string a new line sum, put our sum in here. I'll Do another new line just so it keeps looking clean as it's printing out. And then I'm going to give my title of my message box and have it say totals test. Semicolon. So hopefully now when I run this, it's going to sum up our elements out of our array, store them in this sum variable here that we created. And we created a decimal data type variable called average, and then we're assigning it the value of the sum, dividing it by the totals.length, and again that totals.length is just seeing how long or how many elements are in our array. Of course we got 4 there, we set it to 4, so that's what it's dividing by, is that 4. That's how many times it knows to loop through, is that totals.length is 4. So if we run this, hopefully we get a message box with that stuff in it. And there it is, the totals are $14.95, $12.95, $11.95, $9.95. It sums them all up to $48.80, divides them by 4, and we get $12.45. Guess I could do it here just to show you. $14.95 plus $12.95 plus $11.95 plus $9.95 equals, there's our sum, $49.80. Our sum is $49.80. We're going to divide this by how many? What's our length? 4. Yep, divided by 4. And $12.45 is our average. So we know our math is working. Everything printed out nice. So that's kind of an example here. $14.95. So then we just took summed up the totals of the elements in our array, summed them up, and then divided them by the array length, totals.length, and gave us $12.45. Syntax for a for each loop. For each loop's kind of nice. It's a little bit shorter to write out than a for loop, but when you're doing a for each loop, you can only pull data out of an array with a for each loop. You can't actually put data into an array with it. So the way the for each loop is, you do a for each, you give it a data type, an element name. The element name, you can call it anything you want. Usually you want it to have something to do with what you're working with. And then in and the array name that you're doing, and then whatever statements you want. Here's code that displays the numbers array. And to quickly show you, I don't know about quickly, but to show you kind of how that works, the for each loop, I'll comment this out real quick. So I'm just going to copy and paste some of this real quick to save a little bit of time. So we're using the decimal totals again. I'm going to use the decimal sum again. I'll use the total string one more time because I'm going to use the message box. So now I'm going to use a for each loop though instead of this for loop. And so what I'll do is a for each. And IntelliSense kind of does it for me, but it's not what I want. They're doing a data type of decimal. I do want that data type of decimal in there, but I don't want to call it S. I'm going to call mine total. A lot of times when you name your element name in your for each loop, you just take whatever your array name is and just get rid of the S off of it, so then you're getting each total in your totals array. And then you can do the same thing you did earlier. I do sum plus equal total. And I'm only using total this time because this is what we're using is each total out of this totals array. And now because we're using each total out of this totals array, we don't have to use the subscript or the index to go figure out what it is. So now we can just use that total. I'm going to do total string plus equal total, and that way each total will get printed out to my string. And again, to get it on a new line each time, I could use this environment dot new line. I'm going to get the decimal. I'll use the decimal for the average again. Take the sum, divide it by total string length. Is that what I want? Nope, I want the totals length, and that's the problem with letting IntelliSense do it for you. If it was that total string, it wouldn't actually give me what I want. I guess it might. I guess it could, since it's going to add the 4 into it. But I'm just going to do totals.length, since that's what we named our array. And then I'm going to print it out to the label, since I haven't done that in a bit. I'm going to use string interpolation again. And how do we do string interpolation? $, quotation mark. The totals are, I'm going to put a new line in there just to make it look a little easier to read. Put my total string in there.
Close.
New line, sum, new line to show my average. Gotta close my quotation marks. So that should be printing that out to the label, and then I'm going to put a message box down here again just so you can see it both ways. Message box show, and I will use concatenation on this message box just to show you kind of how much of a pain it is to use concatenation instead of the string interpolation. So totals are.
Is there any instance where concatenation is better than interpolation?
Not necessarily. To me, I prefer string interpolation just because it's so much easier to just type out the text and put your variable names in there rather than having to worry about putting the quotation marks in the right spot and adding the plus signs in there to get them all to concatenate properly and look right. So like, as I type this out, you'll see kind of the difference in the amount of typing and how the layout of it is. So that's my new line. I gotta concatenate it, add my total string, another concatenation, put a new line in here to get it to look right. Another plus for my concatenation. Got to put sum in quotes because I want that to show up on the screen as text. Another plus sign for my concatenation part, another plus sign to add some more stuff into it. Another plus to get average to show up on screen, average. Scroll over so I can see what I'm doing. Got my average. Another plus sign, put my average on there. average, average. And so my comma, that shows what's going to go in my message box there, and then my title of my message box is a comma, and then inside quotes semicolon. So you can see how much extra typing I had to do using the concatenation with all the quotation marks, the plus signs, quotation marks around my new line breaks, and that how much of a hassle that can be to concatenate it. If you miss a quotation mark, it can cause issues, and string interpolation is so much nicer. You can just splat everything in there, get it to look good on the screen. So now if I run this, I should have my label. My label down here should actually show some stuff in it, and my message box should have some stuff in it. So let's run this, keep our fingers crossed. So you can see it's showing the same thing. It has our totals. Totals are, shows the individual numbers, sums them up, and divides by 4. But you can see they both display the exact same thing, but you can see how much typing you save by using that string interpolation. I mean, I don't show my columns on here, but I'm guessing, does it show me somewhere down here where my column is? So I'm on character 101 here. By the time I get done doing that, I'm at character 138. So about 37 less things you have to type out to get it there. And they both end up showing the exact same thing. And again, of course, we've been doing these Windows forms with the labels, and that's all that is stuffed in a label and displays out to the screen. I could have used a text box there if I wanted to, but or a group box or text area, I think it is. I forgot what it's called, but just put a label, threw it in a label, and then of course I threw another one in a message box. So that's kind of showing you the same thing, but using a for each loop, doing it that way. Using this for each loop to check each total inside this totals array, and that's why we don't have to access it with the index or the I, because it looks at each total instead of getting the index based on the looping through it. So that's how you use a for each compared to a for loop, how you set them up, how they work. Here's code that computes the average of the totals array. We just kind of did all that, displaying it out to a message box. So syntax for creating a rectangular array, it's close to the same, but they use this comma in here to show that there's going to be more than one index or element in an index. I guess that's how you say it, element in an index. So you start it out by saying type. You put a comma inside your square bracket there. Same thing, you give it an array name, the new data type again, and then this time you do a row count and a column count. So you can see there they create a 3x2 array here. They're declaring the data type an integer, the square bracket, but they're putting this comma in here so they can hold more elements to show the elements in there. Give it the name numbers. You got the new keyword. Again, it's an integer array. They're saying 3 rows, 2 columns. And here's what it kind of looks like here. The syntax we're referring to an element of a rectangular array. You got your array name, the row index, and a column index. So here you're at row index 0, column index 0, row index 0, column index 1, 0, 2, 0, 3. The next array part would be 1, 0, 1, 1, 1, 2. The next row of the array is 2, 0, 2, 1, 2, 2, and so on. And then finally that fourth part of it is 3, 0, 3, 1. So it's just like we were doing the index before. It starts at 0, 1, 2, 3. That's our 4 parts, our rows of the rectangular array. And then as you go across, we start at 0 again, 0, 1, 2, 3, 0, 1, 2, 3. And that's the 4 columns of the array. So to see something like that, here they're assigning values to it. 0, 0 is 1, 0, 1 is 2, 1, 0 is 3, 1, 1 is 4, 2, 0 is 5, and 2, 1 is 6. So that's 3 by 3 array there, or 3 by 2 technically. 1, 2, 3 by 1, 2, 1, 2, 1, 2. So you can see they do a 3 by 2 array and assign of variables in one statement. Give you an example of that real quick. I'll go ahead and comment this out. And then I'll do data type integer, give it my square brackets. Inside the square brackets, I got to put the comma in there to show that it's going to be a rectangular array. Give it the name of numbers. And then to put the values in, you got to do double squigglies like that there. And then I'm going to do 1, 2, close that squiggly, put a comma, and then you can see IntelliSense is kind of wanting to do it for me, which is fine. 3, 4, close my squiggly, 5, 6, and you can keep going on as long as you want. I'll stop at 5, 6. So let's put my values in there. It's saying there's my first index, the second index, and with the brackets, the first one's in front of the comma, second one's after the comma. So then I'm going to do something like int number of rows. And again, this is technically a variable. So you got to camel case it, lowercase in the front, capital for the next letter, capital for the first letter of the next word, I should say. So we want numbers dot get length. We're going to set it to 0, and I'll explain to you why here in a second. I believe it talks about it on the next slide. And number of columns, get length. So when you're doing the rows, it's going to start at 0. You get the columns, it starts at 1. So I'm going to do an int sum of first row, and we're going to take, we want the element 0, 0, which should technically be, if we're doing 0, 0, it should be 1 and 2 is 0, 0. 3 and 4 I believe is going to be 0, 1, and so on. So sum of first rows, I'm going to do 0, 0 plus numbers 0, 1. And then in my label result, text, since we're putting it into the text. I'm going to use string interpolation again. I'll say values of the numbers 0, 1. New line in there so it looks clean. Number of rows. Number of rows. New line. Number of columns. Sum of first row, sum of first row, so now this should print out the values of the numbers 0 and 1, number of rows, number of columns, and some of the first rows. So if we run this, we'll see what happens. So the value of the numbers at 0 and 1 is that's number 2. So this is our first array here, so it's 0. And we're getting the first element out of there. So if we did 0, 0, anybody know what number we'd probably get from that? So 0, 0 should give us the 1, yeah, since it's array 0. So this whole array here, or the value in these two here, gets stored in this first 0. And then that second 0 looks at the numbers inside of here, so that would be 0, 1. So if it's 0, 0, we run this again, our number should be a 1 this time instead of a 2. So we'll run that again. And we get that number 1 there. Because we look at that first one as 0 and that value is 0. So if we did 0, 1 again, we'd get that 2. If we do 1, 0, what number will we expect to get? We should get 3 because that first number 1 we're looking at looks at the second value of this array in here. And then it looks at the numbers inside of it, and since 0 is that first number, it's going to pick up 3 being the first number in that index. So if we run it again, put it up here so we can see, there's 3 because we're looking at, yep, so we're looking at the array here kind of thing. So like on this rectangular array, it's showing 0, 0, 0, 1, 0, 2. That's kind of what we're doing in here is that's 0, that's 1, that's 2, and then we look inside the 0 and we have 0, 1. We look inside this 1 here and we have 0, 1. And we look inside this 1 here and we have 0, 1. So we could do something like 3, 5, 6, and do 7, 8, and 9. Seven, 8, 9. And so now we'd still have 0, 1, and 2, but now we have 0, 1, and 2 inside of here. So if we look at these values of numbers, number is, let's do 1, 2, let's do 2 and 0. What would we expect our number to be for that? 7, yep. So now we're looking at the array 0, 1, 2. Here's our 2. And then now we're looking at our elements inside of that array, and it's 0, 1, and 2. Our 0 is 7. So if we run this again, we should get a 7 for our value there. So it can be a little confusing. You just have to remember which the first number is part of the array there, and then the next is the index inside there. So of course our number 7, number of rows, it gets the length, and it's showing 3. The number of columns is 3. And then the sum of the first row, because we're not adding all of them together, if I do plus numbers, zero and 2 now, it should give us our proper total, which should be 6, should be the new total it gives us down there. And there's our sum of the first row is 6. It's looking at that first part of the array, and then picking up each of the elements inside of it. 1, 0, 1, and 2. 0, oops. 0, 0, 1, and 2. And that's how it's adding those up. So that's working with a rectangular array. I don't think we use much of these at all in labs, but it's just something to be aware of. I think in the JavaScript class maybe we worked with some of that stuff. Did we not? I don't really remember off the top of my head for a rectangular array where we're doing the 0, 0, 0, 1s like that.
I don't think
Did we
so.
not do it? Maybe I was, maybe on, you know where it was free code camp, where we're getting down to some of those they had you work with, the rectangular arrays in there. So when you guys, first semester students, when you take the JavaScript class, we'll do some free code camp stuff, and they actually work with some of these rectangular arrays. But like I said, for labs and that, we don't use them, but this is just kind of something to get you familiar with, just to keep in mind. Like I told them, and you could probably back this up, is a lot of times when you're coding and you're returning stuff from a database, you'll use a list more often than an array to hold the values coming back from a database and stuff like that. So, but arrays get used quite a bit, so it's nice to know how they work, get used to them. When we switch to lists, you'll like lists a lot more than working with these arrays. So here's a code that creates a 3x2 array and assigns values to it. We just looked at that. Here's a string one that's doing it with strings, and you can do it just the exact same way as we did with the numbers. Another way to create the string one. So the syntax for using GetLength method, array name GetLength, and then the dimension of the index. So as you do the GetLength method to get the number of rows or columns in a rectangular array, to get the number of rows, specify 0 for the dimension index argument, and to get the number of columns, specify 1 for this argument. And that's why it was set up this way here, is because when you're getting the rows, you specify 1 or 0 as the index and 1. Here's code that works with numbers array. Number of rows, get the length is 0. Number of columns, get length 1. And then they're summing them just kind of like we did on that last example I showed you. Code that displays a rectangular numbers array. I'm not really going to go into a demo of this. It's pretty much like we've been doing. You do the for loop, but because there's two parts of the array, you got to do a second for loop to get that other number out of it. So usually when you do a nested for loop, you'll give your first loop, most everybody gives it the value of I for your integer, assigns it the number of 0, just like we did. But here, because it's the number of rows, they do the get length at 0, increment the I, and the nested part of your for loop, most everybody gives it a J value. You see K values a lot. You can give it whatever value you want. You just have to have a different variable because it's running inside this for loop. If you use I again, it'll throw an error because you're trying to use the same variable in the code together. And then when you're wanting to print them out, you don't want to print I and I because it's not going to look quite right or work quite right. So you'll use two different variable names for these, I and J. They're printing it out to a message box again. So here's the variable name there. That's the title that you give your message box if you decide to do it that way. Code that displays the products array. This is just putting out the strings, doing it with strings instead of with numbers. Again, the get length for the row is 0. The get length for the column is 1. Two different arrays, two different variables. Again, what's the /t for an escape sequence?
Tab.
Tab, yep, they're tabbing, just tabbing over to put some space in between them. But that works just the same way as the numbers do up top. You can see if you look at the code, pretty much exact same. Syntax for creating a jagged array. A jagged array just means that before everything was equal numbers, these don't have equal amounts in them. So again, you do a data type, 2 square brackets this time for them, no comma. We're using 2 square brackets. Got an array name, whatever you want to name it, the new, again, the data type and the row count, and then the array with it. We don't use any jagged arrays in our labs, so I'm not going to go too much into it. It's just something nice to know if you do work with arrays down the line in a real world job. I don't know about you. Did you work with arrays much?
Yeah.
More.
But I would say list, like you were saying, list seems to be.
Yeah, more often than not, you're going to be working with lists, just because you don't have to declare the data size and stuff, or the array size and that with the list, and it can grow dynamically. So here they're doing a data type of an integer. You got your 2 square brackets, name an array or numbers, new int. They're putting 3 in it. The number of rows, because there's 3 of them. We have the 0, 1, 2. That gives us our 3. And then they're saying the number of columns for row 1 is 3. Columns for row 2 is 4. Columns for row 3 is 2. That's just kind of how you set up a jagged array. Like I said, I'm not going to go too much detail into it just because we don't use it much in these labs or anything in here, and I doubt Mr. OG uses them over there. I'm guaranteeing he probably used lists more over than that. Have you worked with him at all with that kind of stuff? No. So More than likely, he's using lists to pull his data back and stuff like that. So I'm not going to go too much into these. Syntax for referring to an element of a jagged array is the array name, the row index, and the column index. So here they're assigning values to these number arrays. The row index 0, column index 0, they give a value 1. Row index 1, column index 0, 4. So these would all be one array here. 0, 0, 0, 1, 0, 2 would all be one array. 1, 0, 1, 1, 1, 2, 1, 3. Just kind of like what we looked at a couple slides back, setting these up 1, 2, 3, 4, 5, 6 into them and how we accessed them. 0, 0, 0, 1, 0, 2, 0, 3. It's pretty much the same way. They're just, you can have different values in them now, or different lengths to your arrays. Trying to think of what word I was trying to say. Code that creates a numbers array with one statement. So instead of doing a 0, 0, 0, 1, you can just do new int 1, 2, 3, new int 4, 5, 6, new int 8, 9. So you can see it saves you a little bit of time typing out all the substrings there to put the values in. They're showing the data type is an integer, the 2 square brackets for this jagged array. The name of the array is numbers, and they're just saying a new int, an array, and there's the values you put into the substrings or subscript, subindex, indexes of them. Code that creates a jagged array of strings is the same way. Got a string, data type, the 2 square brackets, give it the name of titles. Say a new string, there's going to be 3 data places in it. The next one has 4 and the next one 2. So if you look, War and Peace, Wuthering Heights, 1984, that's your 3 pieces of data in there. Casablanca, Wizard of Oz, Star Wars, and Birdie, your 4. And then Blue Suede Shoes and Yellow Submarine is 3. So it looks like book titles, movie titles, and song titles is kind of how they're setting these up. And it is titles. So here's another way to do it. A little bit shorter. Titles new, saying it's a new array, and then each new array assigned, and then the values being put into it. Like I said, we don't use much of the jagged arrays. We're going to use what they call parallel arrays, and I'll bring the labs up in a minute and show you what I'm talking about with those, how they kind of interact with each other. Code that displays the jagged numbers array, and again, it's pretty much like we've been doing. A for loop to get the array, and then a nested for loop to get the values out of the arrays, and then the message box, so it just prints them out, kind of like we've been doing. The book has all these demos in it, so if you look through your book or actually read chapter 8, you'll see all this information's in there. Code that displays the jagged numbers, code that displays the titles array, it's the same thing. For loop, nested for loop, that goes through the array, that pulls the data out of the array. Almost like our multiplication table we're doing at that chapter 5 part 2. It goes through the table and then it gets all the data for the table. Common properties and methods of the array class part 1. Of course, we got the length that we talked about, gets the number of elements and all the dimensions of the array. Tells us how many data pieces are in there, and we use that for our loops and whatnot. Instant method is this GetLength, and we talked about that. Getting the length specifies the number of elements and the specified dimension of array. Get upper bound, we didn't talk much about this. It gets the index of the last element in the specified dimension of an array. Yeah, I was gonna say, I think there was an example of it somewhere. Copy, how to copy one array to another array. So you take the array name 1, give it an array name 2, and then the length of the array that you want it to be. Binary search searches a one-dimensional array that's in ascending order for an element with a specified value and returns the index of that value. And then the sort array sorts the elements in a one-dimensional array into ascending order. They give you a couple examples of it here. Code that uses the GetLength and getUpperBounds method. So here they have an array with the data type of an integer. Again, the square bracket shows it's an array. The name of the array, declaring the new array. Integer, 4 pieces of data in it. They give the values of 1 through 4. They do the get length. Of course, there's 4 in it, so it gets the length as 4. So this upper bounds, numbers get upper bound 0. The upper bound is 3. On that, I forgot how I got that. Can you explain the upper bound?
No.
So let me give an example or explain that one better to you.
What Jolly guy has sheet sharp back.
Same thing, isn't it?
Close.
So the upper bound gets one less than the length of the array, so that upper bound is 3 since it's 1 less than the length of the array. So that's why you get the value 3 in that. It's often used with the getLength method. So upper bound 3. I don't recall using that very much out in the real world. So just another part of the array, some of the methods that come with it. Code that uses a sort method. Got a string data type of our array called last names. Put Bame, Taylor, and Mirock in there. Array sort. You sort these last names. You do a for each. It walks through each last name in this last names array.
Mr. G?
Yep.
Doesn't that last thing kind of go back to that debit card thing in a way? On chapter 8, the last line about that debit card thing.
Which part?
The last part on chapter 8, was when I like the last footage of that part.
Yeah.
Kind of go back to that.
The for each part like that? Yeah, the for each, it steps through each of those numbers in that credit card and checks each number. And then I think we compare it to see if it's a number or if it's a letter or if it's a dash or a space and stuff like that. So yeah, so it walks through each one of those numbers in that credit card and then decides if it should mask it. And you can change your masking. I think we mask it with a pound sign, but you can use a splat or an asterisk or wherever you want to mask it. But yeah, that's pretty much what it's doing. It's walking through that number of credit card and then checks each value and sees what it should do. But here this array.sort, it's sorting the last names in alphabetical order, B, M, and T. And so if you need to sort an array and display it in alphabetical order, that's the way you would do that. Binary search, so you have a data type string, and as I said a million times already today, the square bracket shows that it's an array. Array name is employees. They give it the value of Adams A, Finkel P, Lewis J, Potter E. They do a decimal with the sales amounts. Put the sales amounts in here. So they do a binary search for the employee Finkel P. He comes back as the 1 in this index. So then the sales amount takes that index of 1 and goes and searches in the sales amount index or array. And of course we have index 0 and index 1, so it uses the index from this Finkel P's name, 01, uses the index in here, and then goes and finds the index that it's associated with, the 1, and then it gets that sales amount of $42.98. That's kind of closer to what we're going to be doing with these parallel arrays, but not quite. With the parallel arrays, we'll use both the indexes will match up, kind of like this. So yeah, it's close to this. It's written a little bit different, but that's what we'll do with these parallel arrays is we'll find one value in an array, and because the index matches with the other array, it will pull the data out that we need for them. So as you're doing these labs, you'll kind of see how that works. Code that creates a reference to another array. So they have a data type double, an array called inches1. Give it a new double size of 3, use 1, 2, 3. Then they create another array called inches2 and assign it the values of inches1. So now this inches2 array has the values of 1, 2, 3 in it. Well, in inches2, they want to change that index 2, so they want to change 0, 1, 2. So index 2 is actually that number 3. They want to change that third element to a 4. So that's what they're doing here, is creating an array called inches1. It's got 3 values, 1 through 3 in it. Create an array called inches2, copy inches1 into it, and then change that index 2 to a 4, so that 3 will now be a 4 in inches2 array. Code that reuses an array variable. Inches1 makes it a double 20, so that makes a new array with 20 elements. So we reuse that inches1, but now we put 20 elements in it instead of the 3. The syntax for copying elements of an array: you do an array.copy, copy it from one array to the new array and the length that you want. So here's one where it's copying all the elements. Double data type, an array called inches. It's a double with 3 datas in it, 3 pieces of data. There's the 3 values they give it. Got a double. New one called centimeters. They're putting 3 elements in it, but they're not assigning values to it, because what they're going to do is copy it. They're copying this inches array into the centimeter array, and then they're using inches.length to tell what size they want for this array. Inches.length, the length is 3, so that means that centimeters is going to have 3 for the data. They do a for loop, and then they take the centimeters, and each value of the centimeter, which will be 1, 2, and 3, they're going to multiply it by 2.54, and that way they calculate centimeters to inches and set new values for each of the elements in the centimeters array. So that's kind of what they're doing here. I know we don't do any of that in our labs, so I'm not going to go too much into it. Another way to copy elements from one array to another: array copy, from array, from index to array to index. That way you can copy specific items out of an array. And they're doing the same thing here: Martinez, Murock, and Bame. They're copying the last 2. So they're copying it from names, index 1, last 2, putting it index 0 and 2 for the length. Code for a method that returns an array. I'm not going to go too much in this because we haven't even talked about methods yet, and I'm not going to get y'all confused on how methods work and how they're calling these things. It's in the book. You want to look over it in the book. I think chapter 6, we'll jump back to chapter 6 after this. We start getting into methods then. We'll get more into it at that point, but I don't want to confuse you by introducing methods and stuff like that at this point, since we haven't really looked at them. And like I said, here's a method that accepts an array argument. When they pass something into it, it's considered an argument. But like I said, we're not going to get into this because we haven't even talked about methods yet, and I don't want to get you confused or frustrated trying to figure out what some of this stuff means. Like a params keyword, calling the method. I'm not going to introduce you to that yet. I'd rather wait until we get to methods and then start talking about that. Statement that creates a null array. They use the keyword null for it. Statement that will throw a null reference exception. When you hit these null reference exceptions, they're kind of a pain to handle. It's always good to do a check. I think in chapter 7 maybe we start handling validation and null reference checks and stuff like that. So I won't go too much into it, but there's ways of, here's a null reference check here. It's just making sure initials is not null. If initial 0 is not null, go ahead and run the code. When Mr. Kaufman and I both worked on the one project for the Department of Defense, they used a program called Fortify that would run through our code and make sure there was no null reference exceptions or anything like that in there. If they found them, you had to go in and kind of code the code around it like this to check for these null reference exceptions. So if you get a null reference exception, that's kind of the way you handle it. Just check to see if it's null or not, and you'll handle it. You can set your code up to accept null values, and again, way back when we talked about it, maybe chapter 4, we used that question mark to show that it was allowed to use null values in the code. You can set it up like that, so it will accept nulls and should not throw a null reference exception because you're setting it up to accept nulls. But usually null reference exceptions aren't good. It is technically considered hackable, and that's why when we ran the Fortify scans at our one contract, that they made sure we got rid of them. And again, this int saying it can be null, the initials can be null when it has that question mark behind it. We don't code much for that in these labs, so I'm not going to worry too much about it, but just know when you see these question marks like this, just remember, and we talked about it before, that it allows null values, and that will keep this null reference exception for happening. If you do get a null reference exception, you got to do a check to see if it's null or not, and then handle it from there. Arrays that use the following examples. How to refer to an element at the end of an array. So if you want to get the last element out of the end of an array, use here they call it decimal previous month sales is the name of the variable. They're using a sales array here, and again, I know it's an array because the square brackets are there. That caret 2 is saying go back 2 elements from the end and get me that value out of there. We don't use this in labs or anything like that, but like I said, it's just another one of those things to know, another bullet in the holster kind of a thing. If you go out in the real world and code and see this stuff, you probably won't remember it by the time you get a job out in the real world, but just it's there, it's something to know. That's why you keep these books for references. And I think Jamisha was asking earlier about just picking certain elements out of an array, and that's what this is doing here. They don't know what data type they want to use, so they're using this variable keyword, this var keyword. Give it a identifier of first quarter sales. Get that array of sales from back here. Go index 0 through 3, so it gets 0, 1, and 2. Include just an ending index, so it gets 0 through 2 again for that one. This has a starting one. This doesn't, but it just counts the 3, 0, 1, and 2. Starting index, it starts at 6. goes through 7. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. So 6, it goes one more and gets the 7th. By including no starting or ending index, it gets everything 0 through 7. And then by including an index from the end of the array, so it starts at 3, it goes back 2, so it gets 3 through 5, 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, and 5, so it gets 3 through 5. Like I said, we don't use any of these in our labs. Nothing that we code with in this class uses these, but I just want to bring them up and show you that there's some stuff that you can use. Here's where Jamisha was talking about just selecting certain things out of a loop. So here they're just searching or using index 3 through 6 is all they're looking for. That's all they want to pull out of this array and then put it to sales. So it would print out 3 added to 4, 5 and display to the screen. How to use the index and range types. We're not going to get into this because we're not using them. You might end up using them in Mr. OG's class over there, but I doubt it very seriously. Again, that caret 2 says get it from the end. 3 through 6 is the elements that they're getting, so index is 3 through 5. How arrays and collections are similar. Both can store multiple elements, which can be value types or reference types. How arrays and collections are different. Array is a feature of C# language. Collections are .NET classes. Collection provides methods to perform operations that arrays don't provide. Arrays are fixed in size. Collections are variable in size. And I'm going to stop there in the lecture for today because we're going to get into lists next. We've gone through 45 slides already today. That's a lot to ingest on these arrays. The main thing is just learning how to set them up, learning how to use the indexes to get values and that out of them. That's mostly what we do in our labs, is we just pull an index or all the indexes out and print them out to a screen or something like that. So I'll let you work on the labs a little bit today just to kind of start looking at them and get familiar with them. Tomorrow I'll lecture again on lists compared to arrays, and then I'll do a little bit more code demo on arrays that go along with what our labs are actually trying to do. Like I said, most of them are parallel arrays. And let me bring up an example real quick. I don't know if I have chapter 8 open somewhere. No, let me log in and pull chapter 8 up real quick and I'll briefly explain to you. Thought I had these open at one time, I guess not. So like here on our chapter 8 labs, you see I have a zip code and a delivery charge. Each zip code has a delivery charge associated to it. These are parallel arrays, so like if you hit 63101, it's going to be associated with the 20. 63103 is the 12. Down here you have night stayed, the money per night. They're both exact same size arrays. For data's 3 indexes technically. Here you're going to use 3 parallel arrays instead of 2 for video games. A movie database, and then that credit card masker at the end. So parallel arrays just mean there's 2 arrays. They have data that is associated with each other, needed by each other. So if you search 63137, you should get 12 back as your result. So that's kind of what a parallel array is. I'll go into more of it tomorrow, give you some demos as we talk about lists and stuff like that. So Chapter 8 labs and the written test are both open.